Hey guys, welcome back to AlgoYogi. We are doing binary search series and our next problem in the list is time-based key value stores. Let's go to LeetCode. So it's a design problem. Design problems are basically, they have some, algorithm to write, but most of it is just thinking from a design perspective. You're designing like a class. That's what we will be doing over here. We're going to have this init function, and then we have these two functions, which will definitely involve like some binary search because this is from binary search series. Okay, let's read the problem. So design a time-based key value data structure that can store multiple values for the same key, okay, at different time stamps and retrieve the keys value at a certain timestamp. Okay, great. So that's like really straightforward. Nothing can be as straightforward as this particular statement. Now implement the time map class, which is this class. Time map will basically initialize our object of this data structure, and then we have these two functions, void set, which will take key and then a value and then the timestamp, and it will basically store that value next to that key along with the timestamp. Okay, so we have key, value, and timestamp, and for this key, remember, there could be multiple values. That's what they have said it here, multiple values. All right, so and then we have get function that will of course give us key and timestamp, and then we need to return along this list of values. So we have a key, and then we have this list of values that we need to return the value that is at this particular timestamp. Okay, so return a value such that set was called previously with timestamp previous is less than timestamp. If there are multiple such values, it returns the value associated with the largest timestamp previous. So basically like whatever value is before that. Okay, whatever value is before that closest to the timestamp that we are looking for, if that timestamp doesn't exist with a value. Okay, I mean if it wouldn't exist, the timestamp or value wouldn't exist. Okay, I think that's straightforward. This is the example. Let's go through this example. Let us understand what we are asked to do. So I have just I just wrote the input like little nicely. This is the class that we are trying to implement. Initially we will call this this class object, and it will create this empty object where we will basically be performing all these get, set, set, get functions. Okay, so first thing first, we call timestamp. It create this empty I should actually call it more like a dictionary in Python. It will be a dictionary data structure. So what we do is we call set operation with foo as key. So this is my key, this is my value, this is my value, and this is my timestamp. Okay, this is my timestamp. So in this structure, so basically this is what I was saying, this is what we must have created using timestamp class, and this is what we will be filling when we are performing these, when we are calling these set get functions. So when we call set, what really we need to do is we need to have a key as foo, and then we're going to have basically this list of values, and right in the beginning there could be multiple values, but right in the beginning we have bar, and then we have timestamp as 1. So this is my first value. There might be other values. Okay, so and then I call get function. So this is done, and I have this foo as key, and then I have bar, and bar has basically 1 as timestamp. Okay, now I call get function, and in get function I'm basically giving it the key, and I'm also giving it the timestamp. So I will basically look for this key. Foo key is over here. If you see, the key exists, foo key exists, what is the value that is at this particular timestamp? So if you see in this list, we have a list over here, don't we? We have a list over here, and for finding the right timestamp, we can linearly look that up, because if you go through these steps, this is given in such a way, this timestamp always keeps ascending, it keeps increasing. Okay, so we will always, whenever we are creating these different list for different keys over here, the timestamp will keep incrementing. Okay, so it will always be sorted. That's something that we need to understand, like when we are reading the description of the problem. Okay, so what's next? We have basically next operation as get. So we will look for timestamp 1, and then we will return bar as key, so which is our answer over here. And initially set will return none. By the way, it doesn't need to return anything, it's a void function, that we read it in the definition. Then we have next operation as get. Get is basically, again, we are trying to get the value. Get will have key foo. Again, foo does exist in our this map, and then we try to look what is the timestamp that we are trying to look, and this time we are trying to look 3. Does 3 exist here? 3 does not exist, but we, if you remember from the definition, is that if we are trying to look up a time that is not in our list, that means what? In that key list, we will return whatever is closest to that timestamp previously. So if this were to be some value over here, but this does not exist, that means whatever is closest right before that particular key, that particular value. So in this case, we know that value is bar, so we will return bar. Okay, this doesn't exist, so we will end up returning bar, and that's what they have returned over here. Okay, bar has returned, they've returned bar. Now next operation is set. So what do we do? Basically, set operation will give us a key. This foo already exists, by the way. So what do we do? But this time, now we are setting it bar 2 at 4 timestamp. Okay, so what do? We will have this new value as bar 2 with 4 as timestamp. See how these are still in sorted form, because we are following this timestamp, and that will, it's not like later it will give us like timestamp 0 or 1 or something. It wouldn't. That's the whole point of time. Time is linearly increasing. Okay. All right, then what is it? Then we have get operation. And get operation is basically giving us the key exists. What timestamp? 4 timestamp we do have, so we will return bar 2. That is correct. And then basically we have another operation get is this time giving us timestamp as 5. So if it is giving us 5, we do not have it in our list. So what this key we definitely have, but we do not have 5. So what do we return? We return whatever is before that timestamp. Okay, so what is that before it, which is bar 2. So we return bar 2. Now, where does binary search come in the picture? Basically, so far we haven't seen the binary search. We understood what we are going to do. We'll create a dictionary. We will basically, as we are going through the operations, we'll have set operation, take the key, take the value, take the timestamp, take timestamp and value together, key, store the key. If key doesn't exist, then store the key and create basically a list, empty list, and then append that, this key value, key and timestamp, value and timestamp pair. Key already placed in right there. So we will keep doing that. Once we have this list, if you see, this particular list can grow very, very long. So, oh my God, very, very long. So what do we do? Are we still gonna keep this linear search to look up this value? No, that's where the binary search comes in picture. So what are we gonna do is we will apply binary search. We will have our left pointer, we will have our right pointer. We have written a lot of binary search algorithms so far. Not algorithm, binary search is an algorithm in itself. So we have solved multiple problems with that. So we have written it so many times. You can check out the binary search series and you'll find we have written it so many times. So this is all about finding the mid and comparing that mid to the timestamp that we are basically right now looking for, and we will return whatever is before that timestamp, but that needs to exist. Okay, that needs to exist. If this particular doesn't exist, then it needs to exist, and we'll take care of this when we are doing it, by the way, because what was asked to us, like if this particular timestamp is not valid, that means we look for the key basically as m-1. So that will be our answer. Okay, because this will exist if m is basically this index that we are looking for. Okay, so maybe like m represents an index. We compare that with the mid. If this mid timestamp is greater than the one that was sent to us to look for, that means our answer should be mid-1. I hope you're getting that. Otherwise, and if it doesn't, like this still we will set this to our answer and then start again looking for basically in m-1. Okay, I think we are getting it. So let's go ahead and write down the solution. Time complexity would be basically these operations. I guess get operation is what we are basically trying to reduce the time complexity to big of log n. All right. Otherwise, these set and get operations, they should be of constant time, but because it's a list, it was becoming big of n time complexity, which is a linear time complexity. Now what we are doing is we have improved it to a binary search operation, which will enhance our time complexity to big of log n. So I'm going to switch the view here and let's make it look cleaner when the video is being recorded. All right, so what do we do? First thing first, we're going to create our this time map. All right, so let's create self dot time map as basically just empty list, empty dictionary. Then now we have our key, we have our value, and we have our timestamp. So if key not in self dot time stamp, if this not timestamp, time map, if this is not in our time map, that means what? We need to add it to our time map. So how do we add it? So we'll have self time map provided the key, and then have this as basically empty list. All right, now what do we do? If that key didn't exist, that means we have created that key in our map, and now we going to append that value. And if this already existed, then also this operation has to be executed, which means appending to the list that's already there with this key that's given to us. And what are we appending? We are appending value and we are appending time. You can basically switch these values as well, but I think it doesn't really matter. At the end of the day, we will be fetching these values to basically the timestamp we will be fetching to compare it when we write the get operation. Okay, so we write the timestamp and we have these value and timestamp, and we append it to next to the key list. Next to the key there is a list, we append it to the list as we are basically setting these stuff. And now it's a void operation, so we don't have to return or do anything extra. Now is when we bring the binary search in place. So what do we do in binary search? First thing, we have this list. We have this list that that has values and timestamps. So first, let's take that list out from the map. Okay, let's take that list out from the map. So what do we do? Let's call it values. What is values going to have? It will be coming from self dot timestamp. It will be coming from here, and we will be getting it. Getting what? Key. If this doesn't return, then return empty list. Either it should return something or it should return empty list. Okay, so what do we do now? We need to look for that exact right timestamp, and if it doesn't, then before that let's have a variable called basically result. Okay, let's call it result empty. Let's call it empty. I think that's what they were asking us to return if it didn't exist. Okay, so what about now? Let's have left and right pointers. So left pointer would be 0. These are the indexes, by the way, and right would be, because this is a list of values that we have gotten, and these values will have something that we have seen like this. So it will have basically foo, and then we have timestamp 1, then it will have sorry, not foo, bar. This must have we have extracted it by the key, so key must have been, let's say key must have been foo, and this was value as bar, if you remember. Yes. Okay, so bar 2 timestamp 4, or we can say bar 3 timestamp 7. All right, so if we have this now, what we're going to do is we are going to look for that but closest time from left. Okay, either that should exist, either that timestamp should exist. So let's have these indexes. Let's have, my mouse is fucking not working like for some reason. I'm sorry, sorry about that. Okay. What the heck? Okay, yes, the values, and then the legit last index, basically, because index starts at 0. Simple operation, which is basically in binary search, while left is lesser than equals to right, then we are going to basically have our mid calculated. Mid is basically left plus right divided by 2. Now we have this mid. Now let's find out if this mid, so let's say for example we were looking for let's say timestamp 3. Okay, so we are looking for this timestamp that comes from here, that's given to us. Okay, so if we're looking for 3, either my mid gets to 3, so we can say if the timestamp that's given to me, if it is lesser than or equals to, this mid value that I just found out. So values mid, and we stored this timestamp at the first index. First thing is values, 0 index is value, and first index is the timestamp. If this is this basically satisfies, then this could potentially be my answer, right? Either it's equals in my, I was exactly looking for that particular timestamp, or it's the timestamp right before that exact timestamp, like it will occur after it, but this could be a potential timestamp that could be my answer. If not, I will get closer to it. How? Either I will store it into my answer. Basically this will come from the value, and which will be from 0th index. Just okay, otherwise it's empty, or I will increment my left pointer to mid plus 1. Why? Because I was trying to look for 3, and for mid I came over here, and then in this case, this is a little like a bad example, but maybe there was a case let's add some more values over here, and let's say this timestamp was 2, and when I was trying to take out the mid from here, 0 1 2 3, mid is here, and now mid is lesser than this timestamp, this 2 is, and my target is 3, by the way. I'm trying to look for 3 timestamp, key as foo. So if and this could be called bar 2, bar or bar 0 or whatever, I don't care about this, or bar 1. So what I'll do is, when I came across this and I see this is lesser than or equals to my basically the timestamp that I'm looking for, if my if my timestamp actually is greater than or equals to, right, that should be the case, or it should be timestamp is lesser. No, actually it should be greater. If it is greater, then I will move my L to L plus 1, and this could be potentially my answer. Okay, we got it now. So I think this is basically more logical. We just found so this is my potential answer, isn't it? Right? That's what we were doing. And if it is not, then we will switch the sign and we'll just try to run it. Like, we are experimenting. This is the first time I'm writing. I haven't solved it. Okay, so now it should be my right pointer coming to mid minus 1, right? Otherwise I have my result, and I will just return my result. All right, looks pretty nice. Let's try to run it. And I'm still like thinking, let's go back to the definition, what it was asking. If the definition makes sense, then we should be able to run our code. Okay, so it was saying this particular get returns a value such that set was called previously. Correct, it set the value, and timestamp previous is lesser than or equals to time. All right, so if my current time is greater than this mid, or my timestamp is lesser than or equals to values, I am just sick of this, and I'm gonna submit it. Because sometimes if you keep just repeating the logic, oh my god, it just, oh yeah, this works, guys, this worked. Sometimes like brain ka bhosda ho jata hai. Sorry, like literally sometimes like you going through the right logic, you're going through the right step, you're following everything so right, and at some point you just lose it because you have repeated so much. You have repeated it so many times next to the camera and microphone. It's just, you start doubting yourself. But anyway, our answer got accepted. We're good to go. Let's write down the time complexity. Time complexity of get is basically, what is it? Big of log n, where n is the size of this particular list values that we have just collected. Okay, space complexity would be let's call it big of m, where m is the, or m into n, let's call m is the, we can call m is number of keys, and or n is the largest, or I could just say like we have this like bunch of lists. So I'm saying this n is the length of the list, and m is the length of keys, m is the length of number of keys. Okay, and n, the largest size of the list of these values of the okay, little nice problem. Actually, we just wrote it from scratch. We got to the point where we were applying the binary search, and we got it to run in the first attempt. So I think that's a success. Now I am going to take a break. See you guys in the next video. Until then, bye bye.